I'm going to introduce you to a family of forecasting models called ARIMA models. ARIMA stands for Autoregressive Integrated Moving Average Models. You have already learned two of those models, the random walk model and exponential smoothing. And the entire family of ARIMA models is a complete set of models that cover practically anything that you would encounter in forecasting in time series. This would include trends and seasonal patterns and other things that you might need to deal with. ARIMA gives us a kind of shorthand, and so rather than coming up with a different name for every possible different model we could think of, we can describe any kind of model that we want with three parameters, and I'll describe those in just a minute. But each ARIMA model has a triplet of numbers that tell us what it is. And in particular, today we're going to talk about four of those: an ARIMA 000, ARIMA P00, ARIMA 010, and ARIMA 0111. Turns out you already know all of those models. It's just that I have to tell you what those names mean. ARIMA's models are also referred to as Box-Jenkins models. Okay, any particular ARIMA or Box-Jenkins model that we're going to be using can be described using three numbers. The triplet of numbers is P, D, and Q, and ARIMA parentheses P, comma, D, comma, Q is how I name a particular model. And rather than to go through all of the description of what those mean, I'm just going to reintroduce models that you already know and illustrate what P, D, and Q means and how this terminology can be used to describe those models. The reason I'm introducing this terminology is because it gives you a much richer toolkit to work with and building forecast. The most simple ARIMA model would be the ARIMA 000, and that model simply says the average is your forecast. In other words, you take the average of all your data points, and that is the forecast of what would happen in the future. And that model has one parameter, which is just the average. And we don't tend to use that model very often for the simple reason shown here. It doesn't adapt as you go over time. If you're just basing your forecast on a simple average, in that the level of your process changes over time, you're not going to get very good forecast. Rather than using the simple average, we could think of using a regression model to predict the future values. And you would build this regression model in which you would take the readings or the observations of each week as the output variable, and as the input variables you would use the readings of prior weeks. And this, if you use P of those, in other words, I'm going to predict next week based on the last 4 weeks, let's say, that means P is equal to 4. And I would describe that model as an ARIMA P00. It's an autoregressive model, and P refers to the number of terms that we use in that regression. Here's an example with P equal to 1. That is a simple one variable regression model, and I've written it just a little bit differently here so you can see what is going on. Let's pretend we're in week T and we're going to forecast what's going to happen in week T plus 1. The way we do that, we start with the overall average and we add to that a fraction. In this case, the fraction is 0.88. We add that fraction of how much this week exceeded the average. So if this week is above average, we're going to predict that next week is going to be above average, but not as much above average as this week was. It's only going to be 0.88 of that. If last week was, or if this week was below average, we're going to predict that next week is also going to be below average. We tend in business not to use the autoregressive model. It has the same problem that using the average as a forecast has. We're predicting based on a fixed average from the process, and we're predicting how far the observations will fall from that average, and it doesn't adapt very well as the level of the process changes over time. So the ARIMA P00 or the ARIMA 100 in particular might be suitable for processes that are stable, like chemical processes or those kinds of things that you might encounter in operations. But in general in business, we will tend not to use that model. And another reason that we often will not need to use that model is that we could use a model like exponential smoothing, which has only one parameter, and get just as good a forecast as we might get with an autoregressive model, which has at least two parameters. You have the average that you have to estimate, and then you have to estimate the regression coefficient. So if it's ARIMA 100, it has two parameters to be estimated. In general, if it's ARIMA P00, you have P plus 1 parameters to be estimated. Next, let's look at that second number in the triplet, the number that we referred to as D. That number, if it's 0, tells us that the process has a average. In other words, we're using the simple average, or we're using, say, the autoregressive model. Those were both examples of processes where we have an average. If we change that number to a 1, that means that the process does not have a average, but the level of the process changes over time. And in particular, if it's ARIMA 010, that says the way we change the level of the process or change the forecast over time is we use the most recently observed value as the forecast. In other words, the ARIMA 010 is the random walk model that we've already studied. Okay, so you're learning to speak a foreign language, so we'll have to repeat ourselves a few times to make sure it soaks in. So first of all, we describe an ARIMA model as an ARIMA PDQ model, and the P, or the first term in that triplet, represents the number of autoregressive terms that the model has. And the next term in the triplet, the one in the middle, we usually refer to as D. And D tells us whether at this point, whether the model has a fixed average or whether it is adaptive. If D is equal to 0, that means we use a fixed average. If D equals 1, it means the level of the process changes over time and it does not use a fixed average. And then finally, we'll look at the third number in that triplet, and we call that number Q. And in particular, if I have an ARIMA model that has a 1 in the middle, which means the level changes over time, if I put a Q of 0 there, that tells us we're using a random walk model. The most recent value of Z to ZT is the level of the process. If I put a 1 in there, it tells me that I'm going to use exponential smoothing to estimate the level of the process. So that means that ARIMA 011 would be our exponential smoothing model. ARIMA 011 is the exponential smoothing model, and that particular model has only one parameter to be estimated, and that is the smoothing constant alpha. So these are the different models that you know at this point. The ARIMA 000 is the simple average, and it only has one parameter, which is the average. ARIMA ARIMA P00 is the autoregressive model, and it has P plus 1 parameters. It has to have the average plus P autoregressive coefficients. And then you have the ARIMA 010, which is the random walk model, and it has 0 parameters. And then you have exponential smoothing, which is ARIMA 011, and it has only 1 parameter, which is the smoothing factor.